right, good morning. It is actually, if you watched the last video this weekend, it is the very next day. Got a couple more cars to finish up here. Just wanted to make a reminder about the book if you haven't downloaded it, and also that also will apply to my subscribers of the channel in third world countries that I give free subscriptions to. So if you have a free subscription to my paid channel, I forgot to mention, you also get the free download of the complete version of the book. Also a reminder, if you just wanted to buy the book, you can sign into the website. You get a month free subscription with the book. Cancel your subscription at the end of the month if you want to, and you get to keep the book. All right, as you can see, it snowed pretty good last night. So we are going to hopefully not have to get underneath this car because we will get dripped on pretty bad. But this car has a check engine light. That is all that I know. So let's go ahead and take a look at the scan tool. All right, we are going to load up Auto Ingenuity. That's still the scan tool I typically use on this channel because the presentation with the graphing and everything is really good for the camera to help you guys out. A lot of you guys recently, for whatever reason, have been asking about my Xtool D8 that I did a review on a couple months ago. And I still do use that when I'm in the field. That stays in one of my cars at all times. And if I'm helping people out that are stuck on the side of the road, or if I'm doing a field call and visiting a car at someone's house, that's the tool that I use, is that Xtool D8. So if you're in the market for a bi-directional scan tool that's around $400 or so, which is about right now as low as they get. I've noticed that I've got a lot of offers to review a lot of bi-directional scan tools around that price range. So most likely the prices will go down, but Xtool D8 definitely thumbs up on that. All right, let's connect up to this car here. But yeah, I love Auto Ingenuity. I just love the interface with it. And it really presents well on the camera. This is a Honda 2003 CRV. All right, hopefully this will be something good. So typically what I do is I start filming like this, and about 3/4 of the time, I just abandon the project and delete the video because there's nothing good to show on camera. So I always try to generate new material each video. All right, this should be about ready to go. There we are. Let's take a look at our codes. All right, so if you are watching this video, it means that we have some opportunity for a good video or to show something new. Whoa, this is one, a knock sensor. Okay, so this is where that book comes in, because I do have a diagnosis and understanding video series on my paid content channel where we walk through diagnosis of a knock sensor. And so I know what to do here. And also the book has a chapter on the knock sensors as well that we cover. So this will be worth pursuing, whatever the case is. All right, so P0325 knock sensor, Bank 1 circuit. This is a 4-cylinder, isn't it? 4-cylinder engine, so we only have one knock sensor here. So we've got circuit code. Circuit generally means that it is going to be some kind of electrical or signal issue. Okay, so the first thing we need to do is locate this knock sensor. So let's get this vehicle up. So I actually got a second set of these quick jacks, so I can work on 2 vehicles at one time. And the second set is actually a 7,000 pound max capacity, so you can do like full-size trucks and things now. All right, I have a review on the quick jack also on this channel if you are interested. All right, I hope this is easily accessible without me having to get under this car. I raised the car up a little bit too high, but it is going to be underneath. So I'm looking for a knock sensor that'll be on the engine block every time. And typically single wire sensor, its ground is the fact that it's in the engine block. And I usually find it on the back of the engine, but if it is, it's going to be underneath this exhaust manifold, or it may be on the front of the engine under the intake. But either way, it is underneath this car. So, all right, let's see here. Got a little oil leak there, not a big deal. Well, there is no knock sensor on the back. Oh, there it is. No, that looks like an oil pressure right there. Yeah, it is not on the back of the engine. I am very sure of that. So let's look up front. And wow, it's very, oh, there it is right there. Okay, so the splash shielding is in the way, but it is, wow, that is just awesome. It's looks right behind the starter motor a little bit. All right, how do I access that? Okay, I need to remove some of the splash shielding and we'll give you a view here. Now, obviously, most every hack they're going to say, oh, knock sensor code, we'll replace the knock sensor. We're not going to do that. We're going to test the knock sensor. The only trouble is, with the location of where that knock sensor is, it may be very difficult for me to get a probe up in there. Let's see if I can get an angle on it for you. It's right behind the starter motor here. Hopefully, I don't think I'm going to have to remove the intake manifold to get to it, which is good. But my alternative strategy would be we would test that at the PCM, or maybe there's another connector or something that we could tap into to test it. But let me go ahead and clear some space. We'll give you a look. Oh, man, I got water all dripping in my face and everything. I hate these undercar shots as it is. There's a knock sensor right there. That is definitely a knock sensor. So before going through the trouble of removing the splash shielding, there's a bracket that was in the way and everything. I did follow the main wire harness. The PCM on this car seems to be behind the dashboard, so it is going to be easier to try to test this sensor from this location. If we get signal from the sensor, well, then this is going to be a long day, but at least I won't have to be under the car. God, oh God, water just dripped in my mouth. That is the third most disgusting thing I have ever had in my mouth. All right, let's take a look at the wiring here. All right, if we pull back the sheathing a little bit, we see we have typical design. We talk about this on the paid channel. Single wire design. I have seen two wire design knock sensors before. This is a typical single wire design. So it's gonna send signal generated by the sensor. There may also be a bias voltage on this, not totally sure. But that single wire is gonna make this pretty easy. So we'll see if we can get a probe in there and we'll test this sensor out. All right, and actually, you know what? Before we go through that trouble, let's see if we can do this easy way, get data from the scope. So our variables here, of course, we could have where there is a legitimate knock in the engine that is causing the knock sensor signal. That is not likely given that code, but also there is no engine knock. The engine runs perfectly fine. Second problem could, of course, be a bad knock sensor. Third possibility, some type of wiring issue or resistance on wiring. And fourth issue, PCM. I will tell you that I've seen several of these knock sensors, and very often it is not a bad knock sensor. So just replacing the knock sensor, you've got a pretty good chance of getting a comeback, actually. I actually have a friend of mine here in Denver, a viewer that contacted me, Murray, who had a very persistent knock sensor code, replaced knock sensor twice, and came over there, and he's a very smart guy. Murray's a very, very smart guy, and we did a lot of testing on it, and he even made a little gizmo where we can test both knock sensors and even cross over the signals, as a matter of fact, and we were able to determine that knock sensor is generating signal up to the PCM, but we are losing it at the PCM. So it's either a PCM connection issue or he needs a PCM, and Murray, you'll have to let me know whatever became of that if you're watching. But that was a pretty typical thing where any high resistance or anything like that on this knock sensor circuit can absolutely cause this issue. Replacing the sensor won't fix it. All right, so let's go to live data and let's see if there's any kind of a knock sensor voltage or signal detection, and I'm not seeing it. Oh, look at that knock sensor right there. Okay, right now there's 0 volts on the knock sensor. We may have to do a little research on this to see if there should be a bias voltage on there. Could be the sensor is shorted out or something. So if we disconnect the sensor, we should see a bias voltage. I think that's the first thing I'm going to do is try to reach up there and disconnect the sensor and see what happens here. Another thing we can do before we do that, I can take a metal rod. I'm going to bang on the engine block, see if we get any change in knock sensor voltage or knock retard here. All right, so what I'm going to do is take this metal rod here. We're going to tap sharply. It's kind of hard to do while holding the camera. Tap sharply on or around the knock sensor. That piezoelectric chip in there should generate a voltage. We should see that on the scan tool, so let me set up there. Well, as you can see, we've got no response, at least on the computer. So we need to see if there is a signal generated from this knock sensor. First thing we want to do though is see is there any kind of a bias voltage on here. So I'm going to disconnect the sensor and oh man, the location of this sensor is so bad. Let me see what I can do here. God man, I'm getting all dripped on. The snow's really melting now, so it's just running water everywhere under there. Unbelievable. So disconnected the knock sensor. And we see we're not showing a bias voltage. I'm used to there being like a 5-volt bias voltage on there. We talk about this in the paid channel. I'm not seeing it. One of the other possibilities, I have seen knock sensors where they are not functional. The computer signal is not functional unless the engine is running. So you can't just do it on key on, engine off like most sensors. So let's just try that real quick. I'm going to go ahead and turn the engine on. We'll just see if we get anything here. Oh, we do. Okay, we do. So again, the sensor is unplugged. Doesn't look like we've got a bias voltage or we have an electrical problem. So what I want to do, there's a couple tests we want to do. I want to test that knock sensor directly, but I also want to see, is my wiring from the knock sensor to the PCM good? The timing of this is perfect. Over on the paid channel, we are talking about how to make sure you don't blow your PCM. This is going to be one of those opportunities to do that. So what I'm going to do is I'm going to run a 5-volt jumper to the knock sensor wire and see if we can make some voltage on that knock sensor by putting it directly at that knock sensor wire. So that's the first thing I'm going to do. We'll need the engine running for this, so I'm going to go ahead and turn that off while I set up, and that way the engine's not real hot. All right, very basic here. We're just going to put some voltage to that knock sensor wire right there. Start the engine up. We should see voltage if our wiring and computer are good. All right, let me go ahead and put the voltage there. 5 volts. All right, that's all I need to see. Looks like this is going to be a bad knock sensor. We're going to go ahead and test that directly. All right, you can see by the return to its original voltage, I did not blow the PCM doing that. All right, one final test to do here. All right, here we go. Yep, I'm setting up the scope here. Can already see the comments. Hey man, this is a do-it-yourself channel and you've got a scope. Yeah, well, that's because I'm diagnosing a knock sensor that's going to have extremely rapid signal at low voltage. That what am I supposed to do to test this? Use a hacksaw? This is the proper tool for what I'm doing. And the problem is this, and I was guilty of this. I used to be guilty of this. But this mentality that because you're a do-it-yourselfer, you don't use an oscilloscope is completely false, and it's just terrible limiting thinking. You can get an oscilloscope for as little as $100. This oscilloscope happens to be a very extreme generous gift from Robert Roble, that's C5 Diag, one of my viewers, that honestly just changed everything. But here's the thing, if you're a do-it-yourselfer, you still have to know your basic electrical. You still need the right tools to do things. And the other thing I can tell you for a fact, especially since getting this scope from Robert, is that there is also a mentality that you don't need a scope until you've got really, really good electrical skills. It turns out, I've learned, it is exactly the opposite. You get really good electrical skills when you start using a scope. So if you want to make the excuses, because here's the thing, even if I gave this scope to one of those people who criticize me for using it on a do-it-yourself channel, they wouldn't be able to diagnose this either. They wouldn't even know how to plug this in. So we cover a lot of this step by step, how to use a scope over on paid channel. I'm going to assume you guys either know how to do it or you have given up already because you're a do-it-yourselfer and I'm using an electrical device to test an electrical problem from a sensor. So you got to change your thinking on that. I have. It's the best decision I've ever made. All right, so what we're going to do is we're going to set this up. These are going to be very rapid signals representing sound waves. And so we're going to do a 1 millisecond division, and we're going to be on a 2-volt scale. We may have to bring that down quite a bit. It just depends. Actually, I think we will bring it down a little bit because I anticipate this knock sensor actually doesn't work very well. So I'm going to bring that down to about a 1-volt scale. We're going to do the same thing. We're going to beat up around the knock sensor, create a knocking noise. That should activate that piezoelectric chip in there to generate a voltage that we can detect. All right, so we got our sensitivity, I think, pretty reasonable here. And let's see what happens. Now, here's the thing. I mentioned my friend Murray earlier. We found that there was signal from the knock sensor, very good signal from the knock sensor. But then our further electrical testing showed that there is some kind of resistance where the PCM wasn't seeing the signal that the knock sensor actually generated. So that is a possibility here. There we go. Wow, it's super inconsistent. Now I can't get it to work. Oh, there's a good one right there. Although that's not a really good signal. That actually looks terrible. That does not look like a knock sensor signal. So this knock sensor is definitely bad. No question about it. So I'm going to get a new knock sensor for this car, and we will replace it, and then we'll see what it looks like. All right, so we're going to head over to, well, actually, I've got a Prius out there that actually, I think it just needs brakes, but I need to pull that in and take a look at that so I don't make 2 trips to the parts store, especially in a snowstorm. So we will come back to this with a new knock sensor in a little bit. All right, you got to get a gear shift mouse pad for your garage. What we are going to do here is bench test, and let's see, I believe I've got everything set up here. All right, what I'm going to do is just take this metal rod. We should just barely be able to tap on that sensor. And you can see we get very good response. You'll notice also the pattern there. What we're seeing is basically the reverberations of that piezoelectric crystal from the sound waves. So that's why it almost looks like this echo effect. Zoom that out a little bit here and try to... Okay, like that. You see how it's almost like an echo where you've got your reverberations and then they kind of settle out like that, like a fading echo. And that's exactly what this sensor's picking up. You see it's also very sensitive too. Just barely tap on that and we're on a 2-volt scale. Now, let's run that again with the questionable sensor. You also see now why scope comes in handy. If you were to do this on your DVOM, you wouldn't be able to see the pattern of the noise. So even if you generated voltage, you can't tell whether it's good or not. Right now, even just look at the background on that sensor right there. Look at that compared to my new sensor. We can see already we've got much smoother signal just from the background. So there's some interference on this sensor for sure. All right, touching the sensor directly, we see our issue. We do have some of the sound waves, but this is a very noisy signal. See how, let's catch that. Not quite sure why we weren't able to catch this while it was in the car, but it's a lot easier with just the sensor. And what you can see is we've got these very loud noise spikes on the sensor here. We can see our reverberation signal here, but it's very, very, very minimal here. So that you can see that we don't have nearly the same signal. This is a bad knock sensor for sure. We'll put the new knock sensor in and we will clear check engine light codes. Good idea to test drive this at least 2 cycles before returning to the customer, just to be sure. These knock sensors very often are not the cause of the failure. This time we've proven it is. And it's having the right equipment and of course the right know-how from the paid channel material and Dr. Eamon Kamar's book that allowed us to diagnose this car. So let's go ahead and put this back in and we'll run the car, see if we notice any differences in our baseline numbers from the scan tool. And I expect we should at least just see something different here. We may not have any knock sensor activity on a healthy engine. Oh yeah, look at that. Totally different reading from our knock sensor. We've got a little bit of a background voltage reading now. I'm satisfied with that. This is going to be a fix. I'm going to go ahead and drive the car a little bit and we'll close out. All right, guys, I got to tell you, this is just, for me, this is just so fun. I can do this all day except for crawling under the car and getting dripped on with the melting snow and all that. But the diagnostic process here, man, I just live for that, and I get to do that every day with my regular job too as a scientist. So it's the same process. It's the same thing. And having the right tools makes all the difference, as you can see. And the excuse that you've got an oscilloscope, whatever, I mean, now you can get an oscilloscope that would have done what we did for under $100. I've seen plenty of do-it-yourselfers that have engine hoists and engine stands and all kinds of stuff for rebuilding an engine. I don't ever go up to them and go, "Whoa, that's not fair. You've got a bearing puller." It's the right tool for what you're doing at that time. This is the right tool. The scope is the right tool for what I'm diagnosing. How else are you going to do it? So I've changed my attitude on it. I know a lot of you guys still aren't sold on this yet, and you need to be, because I'm not going to apologize or avoid using the scope anymore, because it's 2024 almost. All cars are going to have some very involved electrical systems where you just can't use a pair of pliers and a butt connector anymore to fix everything. It's probably going to be circuit board related, and you need to have ways of being able to detect things that you can't just do with your regular DVOM. But I still do like to keep things simple for you guys for the diagnostic understanding purposes. So we'll still continue to do things kind of the old way and the new way. But the new way is not the new way. The new way is the way. And it was actually always the way. I just didn't realize it until now. All right, guys, hope you enjoyed this. We will see you next time.